Guys, here with the one and only one, the equation that the devil cannot solve. So today we are going to prove the cosine rule given an acute triangle. Why am I saying acute triangle? Because we can also prove the sine rule using an obtuse triangle. So on and so on. So now we are given a triangle ABC, and then they say we must prove that c squared is equals to a squared plus b squared minus 2 AB cos angle C. So what must we do? The first thing that we must do when we need to prove something, guys, we must do some construction yarn. But then because this is the capital letter C, so here is going to be what? Small letter C. Because this is the big letter or capital letter A, so this one is going to be a small letter A. And just because this is the capital letter what? B, so this side is going to be what? Small letter B. Right, and then after that, let's construct the height, right? Perpendicular height. So we're going to say this is our perpendicular height. We can name this side. This is going to be 90 degrees, and here's going to be what? 90 degrees. Let's name our height H. Right, and before we go further, let's name this part this part here, and then we say it's D. Right, it's D. It's the capital letter D. Right, that perpendicular height, which is AD, it's H. Right, and then after that, guys, because we are proving what we are proving, c squared, and then c squared, it's equals to a squared plus b squared minus 2ab cos angle C. We look at this angle C here, right, and then we put any small letter that we like, as long as it's not here close to this side, right? It will help us in future, guys. So this one is going to be what? It's going to be small letter. It's going to be what? X, right? And we know that BC, it's what? It's A, right? And then what? DC, it's what? It's X. So if we say BC, it's equals to what? BD plus what? Plus what? DC. We are going to get something like A, it's equals to what? BD plus X. So, and then if we need BD, we can take this one to the other side. So this is the same as what? A minus, it's A minus what? It's A minus what? Minus X, like that. I'm sure with those things we are sorted. From here to here, it's A minus X, and then from here to here, it's what? It's X, and then from here to here, it's what? It's A. This is one of the most interesting proof in trigonometry, guys. So now, what should we do? Let's focus on triangle what? On triangle ADC. So we can just say, okay, guys, in triangle ADC, like that. And we know that we can apply the theorem of Pythagoras in a what? In a right triangle, right? Meaning this one is our hypotenuse, right? So we can just simply say b squared, it's equals to what? H squared plus x squared, right? And now let's solve for what? For h, right? H squared. And then we take this one to the other side. This is the same as what? B squared minus x squared. It's equals to what? H squared. And then we are done with this triangle there. And then now let's continue. And then we go to that other triangle, which is this ADB. So we can just say in triangle. Now let me try to write. Okay, it's fine. Okay, in triangle. Okay, so that it can be visible. In triangle ADB. Actually, in right triangle ADB. Let's talk mathematical language, guys. And then after that, we still have what? We still have something here, which is what? Which is a right triangle. We can apply the theorem of Pythagoras, because this one is our longest side, right? And then we know that the theorem of Pythagoras states that the square of the longest side, it's equals to the what? The square of two other sides. The sum of the squares of two other sides. Yes, like that. So this one is going to be, what? It's going to be c squared. It's equals to h squared plus a minus x squared, like that. this proof is going to be long. Okay, no problem. Then let's solve for h. So this is c squared minus like that, and then it's going to be what? H squared like that. Okay, before we go further, let's simplify this one. Hey, this one is just to be like this, guys. Sorry. Okay, it has to be there. It's the squaring of a binomial. So let's simplify what's in the bracket. So this is c squared minus, and then let's put the square brackets because we don't want to get some funny ideas there. So this is going to be a squared minus 2ax plus x squared like that is equals to what? H squared like that, guys. And then after that, we can just say c squared minus what? Minus a squared plus 2a squared minus x squared. It's equals to what? H squared. So this, there is an invisible one, so it multiply everything here. So it's minus 1, it multiply everything. Hence the sign changes, guys. So don't be surprised with that. So guys, we are here, right? So we know that h squared is equals to this part, and then h squared is also equals to this part. So therefore they can be equal, right? I should have just said it's equation 1, and then this one it's equation 2. So I can equate the two equations, right? So now, because I want to equate the two equations, I'm going to start with this one, which is what? Let me copy the way it is. It's what? It's c squared minus a squared plus 2ax minus x squared. I first copied the equation number 2. Now I'm going to copy equation number 1. Which is going to be what? B squared minus x squared, like that. Right, so now what should I do? Let me solve for c squared. So this is going to be c squared, and then I take this one to the other side. It's going to be what? A squared, and then I copy this one the way it was, like that. Again, I take this one to the other side, minus 2 ax, and then I copy this one the way it is, minus x squared, and then plus x squared, like that. And then we know this one, they are like terms because they have the same variable and the same exponent, and regardless of their numerical coefficient, so they will give us 0, guys. So we are left with c squared. It's equals to a squared plus b squared minus 2ax. So we are here and we are trying to prove what? We are trying to prove this part. Yeah. So if I'm looking correctly, it means that I'm just left with 2 parts now. Okay, now we need to get rid of this x. But then let's go to our original diagram. We know SOHCAHTOA, guys. Trigonometry. And then cos, it says what? Cos, it said adjacent over what? Hypotenuse. Okay. So we can just say, okay, here we know that cos angle C, it's equals to what? Adjacent, which is what? Which is x, over our hypotenuse, which is what? B. Right. So we can part. We can just say part. And then we go no. We can just say part, and then we say cos cos. Cos what? Cos x divided by what? Divided by b. Let's solve for what? For x. So we're going to multiply both sides by what? By b, in order to get x alone. Oh my lord. Okay, cos angle C, it's equals to x divided by b multiplied by b multiplied by b. Right? They kill each other. Then we're left with x. It's equals to what? I take this b to the other side, which is cos angle C, like that. And then after that, I can copy my original equation there, which is what? C squared D. It's equals to a squared plus b squared minus 2ax. But I know the value of x. The value of x is equals to what? B cos angle C. So it's c squared is equals to a squared plus b squared minus 2a. What is the value of x? X is equals to b cos angle, so b is cos angle vaga C. That's how we prove it, guys. You were with the one and only one. The equation break vaga power.